Let's go through the correct answers here from your assignment from section 1. For problem 1, we had to take a to the 8th times a squared. Well, all right, this is our product of powers property here. So we're going to say this is a to the 8 plus 2 power. When you're multiplying, add exponents. So this is a to the 10th. So number 2 is, hey, look at that. The base is 2 to the 6th times 2 to the 5th. So this should be 2 to the 6 plus 5 power, which is 2 to the 11th. My goodness, that's a very, very large number. If it's really, really big like this, just leave it in exponential form. For number 3, 6 times 6 to the 4th, remember, if there is no exponent, it's implied to be to the first power. So this is 6 to the 1 plus 4 power, 6 to the 5th. Again, very large number. Just leave it. For number 4, getting the hang of this. We're multiplying, so we add exponents. 7 plus 3. This is m to the 10th. For number 5, keep going. Y to the 10 plus 7 power, which means y to the 17th. For number 6, all right, now this is one of our different rules here. This is power to a power. So in this case, again, short version is take 5 times 4. This is n to the 20th. For number 7, negative 8 squared squared. Now, again, this gets really picky here. We're not taking negative 8 and squaring it. That would have required another set of parentheses with that original problem, and that's not what we got here. Leave it as this. This is 3 to the 3 times 6 power. This is 3 to the 18th. Keep going. This is 10 to the 9 times 3 power. This is 10 to the 27th. For number 10, we have, that's supposed to look like negative m times n to the 4th, which means, sorry, we're supposed to take negative m to the 4th times n to the 1st to the 4th. Well, I guess both of them to the first power. Now again, raising something to the 4th power means you multiply it by itself 4 times. So we have negative m times negative m times negative m times negative m. 4 negatives makes that positive. Now, the other way that you can look at this is that this really means negative 1 times m times n, and this is all to the 4th power. So we have to take negative 1 to the 4th times m to the 4th times n to the 4th. Well, negative 1 to the 4th power is positive 1. which gives us the same exact thing. For number 11, to me, there's a fundamental difference here between number 10, where we're supposed to multiply two variables. Yeah, you can't combine those. And number 11, we're supposed to multiply two numbers. Well, we certainly could do that. 5 times 4 is 20. Well, let's just leave that as 20 to the 5th power. I would prefer that we get things as simplified as we can. Here I have one term with one exponent. Now, some of you may have been tempted to take 5 to the 5th times 4 to the 5th, and that's okay, but again, it's twice as long as the answer up above. If we can at all simplify inside the set of parentheses before we take care of exponents, do it. Now, number 12, a times b to the third, there's no way you can put together the a and b. They're two different variables. So this is, again, implied to the first on both of those, a to the third, b to the third. And again, I'm slightly irritated there that they're putting these big black dots in between as multiplication symbols. We don't need that. Just write a to the third, b to the third. That's the way in algebra we write a product. That implies that we're multiplying. Okay, something similar here in number 13 as I just did in number 11. Let's multiply, let's simplify. That's 6 to the 8th power. For number 14, this isn't interesting. We're going to use both power of a power rule and then the product rule. So again, order of operations, we need to take care of that exponent of 2 first. So this is 3 to the 4 times 2 power times 3 to the third. Well, 3 to the 4 times 2 means 3 to the 8th power. But now we have a product here. That means adding exponents. That's 3 to the 11th. Sorry, that was very sloppy. 15, very similar to 14, but we're using variables. So this is b to the 2 times 6 times b to the 5th. Do this product. 2 times 6 is 12. And then our product rule here, add the exponents. This is b to the 17th. And last, number 16. Okay, kind of similar to before. The way this is written, this is one number, this is a different one. Okay, for me to combine both of these into a single value here, I need the same base. Here, both of them are b. Here, both of them are positive 3. Here, one's positive 9, one's negative 9. We have to treat them independently. So this will be negative 9 to the 2 times 4 power times 9 to the second. So this is negative 9 to the 8th times 9 to the second. And I say just leave it like that. If we really, really need to, if this is part of some application problem where we need to find out what that exact value is, then we'll reach for a calculator use the exponent key there. For now, treat those as if they're just different bases and leave them separately. Here we have our power of a product rule. So this means we should be able to take 3 to the second times x cubed to the second. Now, sometimes these numbers are small enough, we should be able to deal with that. 3 squared is 9. And again, our power of a power rule, that means x to the 3 times, again, multiply 3 times 2 is 6. So that should be 9x to the 6th. If those numbers are small enough, if the exponents are small enough, and we can do this part of it without too much trouble and getting to here, the fewer exponents in the end, the better. We're going to try and simplify as many of those exponents as we possibly can. Again, we don't know the value for x, so this has to stay x to the 6th. There's nothing we can do to combine that with the 9. We don't know what that x value is. There's the final answer. For 18, let's do the same thing. We need to take 8 to the 3rd times x squared to the 3rd. Now, again, if that were 8 squared, I would expect you guys to know that's 64. 8 cubed, that's a little bit higher than things we've talked about. And again, power of a power, multiply 2 times 3 is 6. In this case, you could just leave that as 8 cubed times x to the 6th. Perfectly fine like that. 19, we have to take 10 to the 4th times x to the 7, also raised to the 4th. Now, this is a possible exception. All right, if you know what 8 cubed off the top of your head is, that's great. And if you want to write that out, if you happen to know that 8 cubed is 512, or just leave it as 8 to the 3rd. This one we should be able to do. 10 to the 4th is 10,000. 10 to whatever exponent, it turns out that exponent tells you how many zeros it has. So for 10 to the 4th, it's 1 to the 10,000. It's a 1 with 4 zeros. So again, 4 times 7 is 28. So that is 10,000 x to the 28th. And for our last one here, again, we should have 2 to the 6th times x to the 9 to the 6th power. And again, if you want to do that, 2 times 2 times 2 times 2 times 2 times 2 is 64. Or you can just leave it as 2 to the 6th, x to the 54th. Wow. That's a big exponent. Again, practicing here using our 3 different rules. The product of powers, add the exponents. Power of a power, you multiply exponents. Power of a product, separate them, raise every single part of it to that same exponent, and then go back up. Is it product of powers? Is it power of a power? Combine it and write it as simply as we possibly can.